step number 4, you need to compute the test statistic. So in one way ANOVA, we learned that F test statistic is used where the ratio between MS between over MS within. So same thing we do here. So first of all, we need the summary statistic of our data. So we have two factors. We need to get the sample mean for factor A, the row factor, and the sample mean for the column factor. So in order to know the sample mean for the row factor is detergent concentration. We have 3 levels, so we need to compute the sample mean of these 3 levels. So the first level is low. So the first sample mean for the first row, you compute it using the function average in Excel. You select the first row observation, close, press enter, you get the answer. So that is the answer, I wrote it here. Sample size is 2 because we have 2 observations in one row, in the first row. So you drag, you get the remaining sample mean. Sample variance is equal to variance for the sample, select low and high, then close the bracket and then drag. Standard deviation is just a square root of the variance. And then you can get the remaining by dragging. This is the summary statistic for detergent concentration. Now, if you want to summarize the bleach concentration levels, you get the sample mean for the first column by using average, selecting, and then press enter. Then you drag for the second column, you get the answer for the second column. So how much we got here? 186. Sample variance, the function is same, VAR. Then you select the 3 levels to get the first column sample variance, and then you drag to get the second column sample variance. So that's what we got here. Standard deviation is just square root of the variance, and then you drag to get the remaining values. So these are the values which I have summarized in this table. Now once you have done that, once you have computed the summary statistic, now you should know what are the sources of variation in two-way ANOVA. So the sources of variation can be partitioned into 3 parts, into 4 parts. One is variation between the level of the factor A, and the second one is the variation between the level of the factor B, and third one is a variation which we can't explain, which is unexplained variation, and then the last one is a total variation. What we know that the total variation is equal to the sum of the square of the factor A variation, factor B. So factor A, we call it row factor, so detergent, and then B factor is called the column factor, and then the sum of square of the error one. Now we must get these in order to get the F statistic. So how do you get SSA, or sum of the square of factor A? This is the formula you use to get the sum of the square of factor A. So sum of the square of factor B, you can use that formula to get the sum of the square of factor B. Now it is not easy to get the sum of the square of the error. So what we need to do, instead of getting this, we will get the sum of the square of the total because it's easier to get this. Then we subtract the sum of the square of a factor and b factor to get the sum of the square of error factor. So that is, I wrote it here. So we need these 3 in order to get the f value, f calculated value. So first of all, to get this, we have to get the grand mean. What is grand mean? It's just, without looking at this, consider that this is one row data. You want to get the mean of these data, regardless what they have in factor A and B, what level they are having. You add these values and then you divide by how many values you have in total. You have 6 values in total. So divide this by 6, because you have 3 level in factor A and you have 2 level in factor B. So total is 6. So 950 divided by 6. This is called grand mean, and this is used later on to compute sum of the square for factor A and sum square for factor B. So how do you compute the sum of the square of factor A? Sum of square of factor A is computed by B. What is B? B is a number of columns. Okay, so we have 2 columns. Remember that B refers to number of columns. So we have 2 columns. Summation xi bar minus grand mean and square. What is xi bar? It means you have to subtract the row mean with the grand mean. So we have how many sample mean for row? We have 3 different mean here. We have 3 different means. So each mean is subtracted with the grand mean, because grand mean is 158 point, and then you add. And similarly for the third one. Then you add, so you see that we will get this value. And SSB is same. It is equal to, SSB. The formula is A times sum of square of xj bar minus grand mean square. What is A? A is a number of rows we have. So it's opposite, no? When you find the sum of square of B, you use number of rows now. Okay, so we have 3 rows. So 3, then you start subtracting. Subtracting what? The column mean. The first column mean, we found it, it's equal to 130.667, subtracted with the grand mean. Then the second column mean is 186, subtracted with the grand mean. In this way you can get the value of SSB. Okay, these 2 values you needed to later on to compute the test statistic. Sum square of error, as I told you, it's very complicated to compute it. So what we do, we get the sum of the square of the total. It's easier to get that one. And how do you get this one? Sum of the square of the total. Don't look at the factor you have, just look at your data as just one row data. Look at this observation. How do you get the variance normally of your data? just get it in the same way. Sum of the square of the total, each value you have it subtracted with the grand mean. Okay, so we have how many observations? We have 1, 2, 3, 4, 5, 6. 6 observations. Each observation is subtracted from the grand mean. And what is grand mean? It is 158.33. So that is, I did it here and I got this one. SS error, you subtract the SS total from the SSA and SSB, you get the SS error. Once you get the sum of the square of the error, total, and A and B, you need to know the degree of freedom for each SS. The degree of freedom for SSA. A refer to the row factor. Factor A is that one, okay? So how many levels we have? We have 3 levels. So degree of freedom will be 3 minus 1, which is equal to 2. That is degree of freedom. SSB, B is a column factor. How many levels we have? We have 2 levels, low and high. So 2 minus 1 is a degree of freedom. We get 1. SS error, the degree of freedom will be the row we have A minus 1, which is 3 minus 1, and the column we have B minus 1. So total, you just need to multiply 2 with a 1, you get SS error as 2. SS total, you need to add SSA, SSB, SSE to get the degree of freedom for SS total. So we wrote it here, okay? Degree of freedom of rows, we know that we have number of rows as 3, so degree of freedom will be 3 minus 1, which is 2. Degree of freedom of columns, we have 2 columns, so degree of freedom will be 2 minus 1, which is equal to 1. Error will take the multiplication of degree of freedom of row times the column 1. So 2 times 1, which is equal to 2. Degree of freedom for the total is just the addition of these degree of freedoms. So it's equal to 5. Now what is MS? MS is called mean square. So mean square for the row is sum square for the row divided by its degree of freedom. So you divide SS by DF in each one, then you get the MS, mean square error. So these are the formula which we use. I have to delete this one. Once you get the MS square, you can get the F calculated, because F calculated it's just the MS of the row divided by the MS for the error. If you want to get the calculated for the factor A, so you need to divide MS for factor A divided by MS for error. If you want to get F calculated for factor B or column factor, you need to divide MSB over MS error, and that you get. Now we need to compare the calculated with the table. So we have 2 calculated value, we need 2 table value. The first table value, you get it by the F distribution table using the degree of freedom 2 and the error degree of freedom 2, because we want to find the F table for the row factor. Okay, so that is F table. The degree of freedom, the first degree of freedom, number of degree of freedom for the row is 2, for the error is 2. So table value for the row factor is 19. The table value for the column factor, we know that we have degree of freedom for the column is 1, for the error is 2. So the table value for the column factor is 18.51. Now comparing these 2 values, we can see that the calculated value in the first part is greater than the table value. Again, the calculated value for the column part is greater than the table value. So in that case, in both cases, for the both alternative hypotheses, we need to accept and we have to reject the null hypothesis. So both null hypotheses are rejected It means there is an effect of detergent concentration and bleach concentration